why do we have DevOps now? We have DevOps because we got so tired of things not working and not having the time to fix anything. We said our culture needs to change to improve that.
You know, just sort of adopting DevOps doesn't work. You need to really change the way an organization works and thinks.
Coming up with names in this industry, I think we should be banned from naming things. Particularly naming things after what they're not. You know, NoSQL, serverless. Whoever named those things, stop it.
Very last keynote. Wow, this was fast these days. Glad that you're here. And it's just about announcing the next keynote. This keynote is about the problem of speed, of flow. DevOps is about speed and flow, not only, but very often. And of course, there are lots of obstacles inside an organization, inside your tool chain, on many, many different levels. And let's see what Dr. Jekyll and Mr. Hyde, no, Dr. DevOps and Mr. Lean are telling us. Please give us a warm hand to Dr. DevOps, Mr. Lean.
Thank you. So we are two colleagues from T-Systems. Next slide, please.
Yeah, technology, you know.
So my name is Boris. I work as a lead architect for DevOps and Cloud for T-Systems International.
So now it works. Yeah, my name is Bernd Rederlechner. I'm one of the chief technologists at the moment of T-Systems. And we want to tell you today how to release your flow breaks. The whole story started when somebody told me something like this. He started with coming to me during a break. And if he starts like this, well, Mr. Rederlechner, you know, you have to run for cover, more or less. So he said, we tried DevOps and Agile in our organization, and, well, the technology worked, but our business units tell us we are not get any faster. We are not perceived any faster. Yeah, and you take this, you handle this in the moment, but after coming home, you think of it. And then, when I think of it, I started in the first place to make some research about what does the internet tell us about this. The first thing, and this is a very prominent one, it's the State of DevOps Report 2018 from Puppet. And here they said, well, where do we start? And most of us start, yes, deployment automation, version controlling. And interestingly, these first two are really DevOps, Dev and Ops. And the third one is, because I don't get Ops so much, I do build automation only in Dev. And the fourth one is the complementary one. It's the one, because I don't get the Dev guys, I automate only in Ops. There is indication that there's something right with what the CIO told me. So here, let's research further. And then I found this one. Yeah, it's something you can ask. Measuring success of DevOps initiatives. How do you measure success? But I would never take these categories. Yeah. What is my primary factor? Internal? Is it external business? Or, I don't know yet. And it diminished a lot. More people know, meanwhile, what they want to do. But the voters' movement is this one. So most of them decide to go to internal criteria. There has to be something with this, what they told us. Okay. Then, from what you know how DevOps and Lean works, you start thinking. And thinking goes like this. We are not measured by the things we are doing. We are measured by the things that how we are seen from the outside. And maybe it's a good idea to look at our job in the way of how we are perceived from the outside. So what's the perspective of the outside? Let's take the perspective of the end user. And the perspective of the end user, in the end, is the perspective of somebody who doesn't care about what tools we are using. It doesn't care about how our processes look like. He simply does the following. He has needs. And he expresses these needs by different kind of ways. He gives us concepts. He gives us sometimes something, real specifications. In the new world, in the agile world, they give us user stories. And in the end, he doesn't care what's going on in the IT factory. He's just waiting. Waiting on the other side of the black box and waiting for this to happen. I hope it happens. Yes. He simply wants to get the small elephant delivered. And formally speaking, this is the lead time, the time it needs to produce the elephant. And the average lead time is the thing that you perceive if multiple things go out of the factory, one after another. So how long does it take? The first one rolls out, the next one, the next one, and the next one. And the average lead time gives you an indication how fast are you perceived. Even if you have two things that roll very fast, in a very fast frequency, one after another out of the factory, if you have later on one who needs a longer delay until it rolls out of the factory, you will always be perceived by the longer delay. You will never perceive by the speed that you had the one time when one gets fast out and the next one gets fast out. Knowing this, you have to carefully review how you optimize your IT delivery. And reviewing the thing, there is a way, if you're in the model of average lead time, you can apply something which is called Little's Law. Little's Law is from queuing theory, and it tells you something about flow. And the interesting thing, applying Little's Law to the scenario I've shown you before, it says you have only two levers to apply if you want to get faster. The one lever, which is in the upper part of the quote, is work in progress. The more work in progress you have, the slower you get. The less work in progress you have, the faster you get. The thing is, you want to minimize the average lead time. This is why the work in progress has to be small. Okay? The other part of it is throughput. And it is not meant the throughput of your working station, which, if we look at IT production, this does not mean how fast you deploy. This does not mean how fast you develop. It is just the frequency and the throughput that is perceived from the outside, how far the factory is able to roll out things. And if you want to optimize this, you have to increase your throughput as much as possible. We will look at this closer in a second step. The first step is there are dependencies between the different things. And we have started not with the work in progress in our picture before. With what we started was the batch size, the order size, the size of what we have to deliver all at once. And the thing is, if you want to have many things all delivered at once, you automatically have a big work in progress. Because work in progress is everything you're working on and you began to work on. And you have not finished yet, sorry. Okay, So if the batch size is high, the work in progress must be high. And if the work in progress is high, little slow tells us the lead time gets high, which means we deliver slow. And now we want to optimize throughput. And throughput is very, very beast, because it is not by law connected to the work in progress, but from what we know how the things go. Because we know if we put a lot of parallel work in such a factory, and if the factory is not made for this much parallel work you put on it, then you overload the people. They have to make task switches because you have less production lines than you need for production, and you make a lot of parallel things more than you have production lines, and you have to switch. So throughput is implicitly diminished if you increase the work in progress, which makes the situation not good at all. Okay, no problem. Let's look at the levers. Let's find out what we can do, because it's not so good to talking about things we can't do. It's better to talk about things we can. So let's talk about work in progress. And part of the thing already starts before the factory. And I want to have you look at the point where we put these specifications before the factory. What we usually do, and what our customers or even our product owners, or something in Germany is called Fachseite, the one who drive the business, whatever, they give a specification with a big white elephant. Really, a big white elephant. And they do it in this way. They tell us exactly how we have to solve the problem. Build that, exactly that, and no other discussions. Okay, but where aren't your view and you change to the problem space? And what you do now is you do something you already know very well. There's a structured way to describe user stories. And it starts with who is requesting it. Then you say, what is the task to solve? You don't say, I want to have an elephant. So you say, I want to have a tool for heavy weights, to transport weights. And some constraints on it. It should really do heavy loads. It should pass unpassable areas. And yeah, ecological sustainability is something we all talk about already, at least since Trump. So what happens now to your batch size? Because you don't get a solution, you can think about the minimal one. You can think about a small elephant instead of the big one. You can find out what is the essential thing I have to deliver fast to the customer, so that the customer can tell me, are you on the right path, or have you to pivot? So you diminish it in the way that you have one order which
moment to the end user. So the average lead time would be something like, oops, infinity. So what do we have to do first? Of course, we need to build our DevOps toolchain, and this is setup time, and you have to take this into account. If you really build your own IT factory, your own DevOps toolchain, then the end user has to wait a very long time, because the first feature that you deliver, of course, cannot be delivered before you have set up your DevOps toolchain. So this comes in the second step, the feature one, and then, of course, additional features. That's what you have to take into account if you build your own DevOps toolchain. So let's look at a typical company. Usually we always have silos, And what does this mean? So if you're producing in parallel different projects or products working for different customers, as we can see here with the silo A, we have, of course, a DevOps toolchain that is silo A flavored. And now a second silo starts doing the same thing. Of course, they're delivering different features, but I guess they could use the same DevOps toolchain, but they started later. They have different people with a different mindset maybe, so they end up with the silo B flavored DevOps toolchain. And this can be, of course, the same with silo C. So at the end, you have a bunch of different tool chains, which is, of course, hard to maintain. And if you want to change from one silo to the other, you don't know what the people are using there as their tool chain. So we have repeated waste. We invested several times money, resources in setting up the tool chain. And we have this poor synergy, yeah, because they didn't sit together and build some. Everybody will look at you, yeah? What the heck, what is the problem here?
Look, even on the toolkit, they are writing that the flickering red light is included. So, yeah.
Day.
And maybe I have a customer in Silicon Valley, a Silicon Valley company who handed over their microservice system to us. They want to have us as the systems running their microservice system. And as I said, you have to get it done by your own to get our tool chain run. Mm. And we did not make it at all, because what we got is a tool chain which was deeply rotten in any way. And if the tool chain is deeply rotten, it is not that it's better because you have the tool chain, because it's worse, because many things are not documented. They are even not documented anymore because everybody says it's in the code. You have to debug something somebody foreign has done, and in the end you get much slower than better because you only cope with complexity.
Yeah. And sometimes there's also a misunderstanding what a tool chain is. So a tool chain is not having some tools, yeah? It's not a set of tools. They all really have to work together. So it's a production line in perfect synchronization. So if one tool has finished, delivered a result, this should be, of course, automatic tool chain. And that's also, of course, what we had in mind when we built our tool chain. So here we can see the developer, or he has finished something very important. It's packaged in a new container format. It's called egg. Now it's put into the delivery pipeline. As you can see, we have automated testing involved here. That's very important. QA, security check, of course, what's inside the container. Clean APIs, important. Then maybe we measure how big is the container, how much memory do we need to run it. And of course, then we deployed to the target system so that the customer gets his release, his feature.
Yeah, but Boris, there was something wrong, because the elephant is not the customer.
But of course, we have a lot of elephants, now the blue one. Yeah. Okay, so what did we do at T-Systems? So the idea was to help all those customers out there in the world. They are needing a DevOps tool chain, a managed DevOps tool chain. And one of the hard problems that you have to face when you start building your own one is that it's not just building this IT factory we have seen, it's also taking decisions about what kind of steel do we need? What kind of concrete do we need? Yeah? Do we take the red doors, the white doors for our factory? And as you can see here, if you Google the DevOps tools that are there outside in the world, you come up with around 80 tools, getting more every day. So it's absolutely unclear. Yeah? Of course, you can ask some colleagues, do you have experience with this or that? But it's really hard to find the best tools available. And usually, if you really start developing your own tool chain just for one project, then there is no time to do a deep evaluation of all the possibilities. So that's what we did for you. We really collected all the requirements, mandatory requirements, optional requirements, nice to have features. Not only hard requirements, also things like, is there a common use of the software? So a niche product isn't that interesting because we should always use something where there is already a community. It has to be actively maintained so that you get updates and security patches over time. Price might be also interesting, of course. And it's also important not just looking at the single tool, because I said a tool chain means connecting one tool with the next tool. So this was also important for taking our choice. And the winner is, so that's where we ended up. And maybe you already know some of the tools here. Our main message is that focus is not a bad thing. So our idea is that DevOps teams usually should really focus on the different steps in a DevOps cycle. So the tool chain shouldn't be the goal. It's of course nice to build one. It makes some fun. But at the end, your customer measures you. When do I get the first feature? When do I get my first delivery? If you take too much time for building your tool chain, this will be a long amount of time. So what we are offering is a solution that is running in a public cloud. You can use it from everywhere in the internet. And of course, the good thing is collaboration. So you can work together with other customers, with your customers, or with other companies where you work together on problems. That's the idea. So you get an exclusive instance of the tool chain here. We have a mix of commercial and open source products. So these are some well-known tools from Atlassian. Is Jira for things like a product backlog Confluence for collaboration. It's Bitbucket for the Git repositories. If you do real DevOps, everything is code, infrastructure is code, test code, and so on. We use Jenkins with the Blue Ocean interface. Delivery pipelines for this, we offer a lot of libraries that you can use to build Docker containers. We use the Nexus repository for the Docker container images. SonarQube is for source code analysis. Everything is built around Docker. So our idea is you always need to be in the situation that you have immutable images. So build once and then deploy your container, which is an immutable image, to all of the stages that you have. Do all the proper testing at the end, deploy the exact same binary on the production platform. For the deployments, you use the Rancher tool, which can set up Kubernetes on any cloud in the world. And we also offer Prometheus and the Elk stack, which can be used for monitoring and for log file analysis.
Boris, interestingly, you said that we really take care and say, do ephemeral here, which is knowledge. Because if you do, we do not only deliver the tool chain, it's only a tool. And a fool with a tool is still a fool. You get the expertise you need to really get it run as fast as possible, which is even a more important point than having the tools. Because technology is not what, technology is a help, but it's not the world.
Yeah, absolutely.
Yeah.
So that's why the idea was also to keep the tool chain as a software as a service very cheap. Yeah, so everybody could enter it, but we can of course help you with consulting and training, so getting really onto the DevOps train.
And to help you even more,
yeah, we have coming up the DevOps simulation in the Atlanta room. Yeah, so if you want to join us, it's not that technical. You don't have to write code. We don't need to use some tools for it, just your fingers and your brain. It's very fun, but you will understand all the fundamentals that we have seen, especially with Bernd's slides about lean production.
Yeah. And in the end, the only thing you can do is feeling is believing. Because we can tell you a lot of things, and it looks like, I plundered the university about my ideas I had. But we want to have a very, very practical simulation, which resembles a little bit development, but takes only half an hour about simulation itself. And you can really feel the flow. And we invite you to come with us in Room Atlanta to feel the flow. Or if you're still more in technology, which is okay in the end, which is really okay because we all love technology, you can come to our booth, and we have 3 things to offer. We have our public cloud, Open Telecom Cloud. Few people know that we have something, a German public cloud. We can demonstrate you the DevOps as a service if you want to. And we have a nice little artificial intelligence demo where we learned a computer to take photos and to draw like the old artists from history. Thank you a lot. Hope you had fun a little bit the last half an hour. Thank you.
Thank you very much, Bernd and Boris. As I said, this is the last keynote. This was the last opportunity for all of us to meet here in the big hall. I would just like to say thank you for coming. Thanks for joining. Give us your feedback, and it was great to meet you all here. And I would just say let's give a warm and super loud applause to all the great speakers who did a great job here. Thanks very much to them. I hope I see you soon at some of the future conferences, be it the future DevOps conference or some other conference. Just in case to let you know, we're also running a serverless architecture conference in April in Den Haag, or in The Hague, how to say in English, yeah? If you're interested, feel invited to just join us. Enjoy the afternoon, enjoy the workshops tomorrow if you book them, and have a safe trip home. Thank you very much.
Why do we have DevOps now? We have DevOps because we got so tired of things not working and not having the time to fix anything. We said our culture needs to change to improve that.
You know, just sort of adopting DevOps doesn't work. You need to really change the way an organization works and thinks.
Coming up with names in this industry, I think we should be banned from naming things. Particularly naming things after what they're not. You know, NoSQL, serverless. Whoever named those things, stop it.